At a small toy manufacturer, a day's salary for an assembly worker is $120. The supervisor wants to determine the average assembly cost per toy. An assembly worker can assemble up to 200 toys in a day. A. Write a model for the average assembly cost per toy if the worker puts together T toys in a day. Well, the average assembly cost is what we're looking for. So let's call A of T the average assembly cost. The assembly worker earns $120 per day, and during the day he or she puts together T toys. So the average assembly cost, A of T, would be the $120 divided by the number of toys assembled. B. What is the average assembly cost per toy if the worker puts together 100 toys in a day? 100 toys, so that means that T is equal to 100. A of 100 would be 120 over 100, which is 1.2. So the conclusion, if the worker puts together 100 toys in a day, the assembly cost per toy is $1.20. What would be a reasonable domain and range for this model? All right, well, let's assume that T, well, we know that T is the number of toys. So negative numbers are not reasonable. Also, 0 is not reasonable for the model, because if I substitute 0 for T, then I would have 120 over 0, and that doesn't make any sense. Right? That is undefined. So the minimum number of toys that can be assembled for this model is 0. So I would say for the domain would be 1 is less than or equal to T is less than or equal to 200. Remember, we have an upper limit for the number of toys in a day. Now, to find the range, well, what we can do is substitute those values in for T. A of 1 would be 120 over 1, which is 120, and A of 200 would be 120 over 200, which is 0.6. So the range would be 0.6 is less than or equal to A of T is less than or equal to 120.